Hello and welcome back. Today we will talk about an amazing topic related to data protection. We will talk about RAID. So, what is RAID? RAID stands for Redundant Array of Independent Disks. The name indicates that the disk drives are independent and are multiple in number. How the data is distributed between these drives depends on the RAID level used. There are different kinds of RAID setups which provide various levels of data protection, storage performance, and bigger storage space. In a very simple way, we have some physical disks will be grouped by using one of RAID levels like RAID 0 or 1 or 5 to provide a one logical disk on your system. So the main advantage of RAID is the fact that to the operating system the array of disks can be presented as a one single disk. So let's explain more about RAID levels. One of standard RAID levels is RAID 0 or striping. We can describe RAID 0 as a connection of two or more physical disks to appear as one big and fast logical drive. So how does this work? The way RAID 0 works is you take two drives, for example each one is 10 GB, and if your data is A, B, C, D, E, F, so the computer will write alternating between the two drives. So you will find A in this drive and P will go to this drive and C will be here and D will be over there and so on. So what happens is effectively half of your data is stored on each drive, and this gives you a performance boost whenever you're reading or writing large files to and from your drives. But the disadvantage is if one of your drives dies, you only left with half of your data. Unfortunately, the half of your data doesn't work like this. So it is not usable data. So with RAID 0 you get a bigger storage because the total size of the array is double size of one disk. In our example is 20 GB. Also you will get fast storage, but you will lose the data protection. RAID 0 doesn't protect the data, so we need another type can provide data protection. It is RAID 1. So how it is work? The way RAID 1 works is you take two drives, for example each one 10 GB, and if your data is A, B, C, D, E, F, and you want to write this data in RAID 1 drives, so A will go to this drive and this drive, B will go to this drive and this drive. So each of these drives actually contains all of your data. You might get a slight boost when you are reading from the drives, but in terms of writing data to the drives, since it has to be done to both of them individually at the same time, it works exactly as the same single drive. But the advantage with the RAID 1 is any data you write is completely safe from hard drive failure. So if this drive goes down, you still have all of your data completely safe. The system just gives you a notification, hey, there is a hard drive failure, please fix it. So all you have to do is just bring a new drive and replace the failed one and tell the array to rebuild itself, and then this drive will automatically copy itself over to the new drive. So with RAID 1 you can protect your data, but the total size of the array is only the size of one disk. So in our example it will be 10 GB. So in RAID 0 we didn't get the data protection, and in RAID 1 we got the protection but lost half of the total size because mirroring the disk. So we need something else can provide protection for the data and don't waste much space. It is RAID 5. So how it is work? The way RAID 5 works is you will take 3 drives, for example each one is 10 GB, and we will store the data on 2 drives and generate another data called the parity by somehow and write the parity on the 3rd drive. To understand the parity, I'll give you a simple example. If I told you solve this equation, 1 plus 4 equal x. So what is the value of x? Of course it is 5. So if we missed the number 4 and give you the same equation, 1 plus x equal 5. So are you able to get the missing value? Yes, of course. 5 minus 1 equal 4. So it's easy. Also our computer will do the same, but because our computer is understanding only digital numbers, zeros and ones, so it will use something called XOR to generate the parity. For more details about XOR and how it is work, I'll add a document for it. Now you got the idea. If we have 3 drives configured as RAID 5, and for example we want to write this data A, P, C, D, E, F. So you will write A in first drive, B in second drive, and generate parity in third drive. And again you will write C in first drive and D in third drive and generate parity in second drive, and so on. So in RAID 5, data and parity will be striped across the drives, and if any drive goes down, for example this one, we will replace it with new hard disk, and the array will generate the missing data from the other 2 drives. So you will not lose any of your data, and now the total size is 30 GB, but the actual data is stored on 20 GB and 10 GB for parity. So we got protection for the data, and we use 2 by 3 of the space for storing the data. Thank you for watching, and see you in next lesson.